Alrighty. Um, Hello and welcome to our webinar on autonomous mobility at airports in Europe. This is a series of webinars where we are going to talk about the implementation of various autonomous vehicle strategies, particularly in the airport environment, but also in public transportation as the technologies quickly change. We're going to look today particularly at Schiphol Airport and at Brussels Airport. And we're going to talk about the implementations, the technologies, and the emerging use cases for this technology. Overall, we've come a very long way since our organization started studying and working with you on the use cases. Frankly, when we began autonomous vehicles in America, now autonomousvehicles.org, along with global mass transit, the ideas were not as evolving as fast as the technology. The technology is such that when we ran a conference on these subjects only 4 years ago, we'd show a video of an autonomous vehicle making a left-hand turn against mixed traffic, and people would sigh with anxiety at what was going to happen. Now it's a given. The same thing with an AV going through a roundabout, proven to be in almost any statistical basis a safer use of a roundabout in traffic than a human driver. We're looking at a world where simulators have created quote unquote hell worlds for autonomous vehicles on the airport, on the tarmac side, as well as on the public transit side. And these hell worlds and simulations have enabled us to advance very significantly in all applications of the autonomous vehicle strategy. And this now includes towing the airlines, handling baggage, first mile, last mile shuttle services on the airport grounds. The airports have proven to be an ideal situation in which to do the implementations because we have a more controlled environment, because we have a greater need to move people. But at the same time, we're looking at an environment where it's very, very complicated because we're moving hugely expensive pieces of equipment in terms of the airplanes. We're in the most secure environments on this planet. And we're in environments that are handling very significant numbers of people. The technology is going forward an accelerated way, partially because there's heightened interest, sadly, given the Ukraine war, in autonomous vehicles in the battlefield and what that can mean. And so that, along with a desire to do some obvious things, reduce road congestions by having fewer vehicles driving more of the time, improving safety overall, lowering emissions. We will talk about sustainability in each of these use cases. And then quality of life issues for people that need special access and the greater age of the populations, particularly in Europe and North America. We're now also in an environment where public resistance is changing to autonomous vehicles is changing very, very quickly. It has a lot to do with some of the use cases we'll talk about today. The airport applications give millions of people a chance to try an autonomous vehicle, particularly in the form of shuttles and platoon shuttles. And now we have, through the transparency, I have to say, particularly of Waymo, data that shows that the autonomous vehicles are moving at a rate of over 90% fewer incidents in terms of accidents, let alone serious injury, let alone deaths on the roads. So a better environment is coming along, and that's the subject of this morning. And with that, I will introduce the panelists briefly, and then we'll go right into discussion of Royal Schiphol Group's implementations in Amsterdam. So we have Don Boot, Strategy and Innovation Advisor, Royal Schiphol Group. He is part of the autonomous operation team at Schiphol. Schiphol is handling 87 airlines, 1.5 million tons of cargo a year, and 69 million passengers. We have tow tractors on site. We have autonomous vehicle tests. We have hydrogen-based tow tractors at Schiphol, and we are looking at fully autonomous airside management by 2050, not very far away. And we have AI and data-driven systems, and the implementation, which Dan will particularly talk about, of smart ramps, where partners on the ground, such as KLM, are looking at doing things like AV/robotic implementation for ground power. We have a working environment there where we're managing sustainability at Schiphol. There's a focus on reducing both vehicle and aircraft emissions by much smarter handling. With Don, we will have Rosina Cote, Innovation Lead at Royal Schiphol Group. She has worked on initiatives for autonomous, intelligent, and resilient airport operations. She's managed in an environment of changing leadership, and she has done autonomous GPU connection work, autonomous passenger transport, sustainable taxiing. She's known for her ability to bridge technology innovations with organizational transformation. It's noted in her biography an appetite for risk, and this is an environment where you need that perhaps above all other skills. And the two of them can talk about the airport of tomorrow. So I will introduce the next panelist in about 20 minutes, but if we can now switch to the presentation on Royal Schiphol Group's experience in Amsterdam.
Thank you, Yu. I'll kick off the presentation for the both of us. Let me start sharing the screen. Are you all able to see the screen?
Yes.
Thank
you.
Perfect. Yeah, perfect. So thanks for that introduction, Yu. It's a pleasure to be here and to discuss our ambitions towards working towards an autonomous airport operations by 2050, but surely we are starting now, and we are expecting between the now and the next 5 years to see the first implementations that we'll be able to scale. But of course, the airport environment, there's many processes, a lot of implications to and a lot of grounds to cover there. So it will take a while before we have reached a fully automated airport operations. But why do we want to work towards this ambition? We have a lot of major challenges at our airport, and I think it's not just at our airport. I think aviation in general is facing same challenges globally. I think in relation to working conditions, it's no longer accepted that we impose our employees to very harsh working conditions, heavy labor, working in tight, uncomfortable spaces, weather circumstances. So we need to improve there. We need to improve the working conditions for our staff. We are also facing a very tight labor market. So in what we see after COVID is that it's been very hard to get the people back to the airport. And even the people that are here, it's difficult to retain. But we also see, due to the aging population, that in the future this problem will only increase. A specific case there is what we see, that our bus drivers on a day-to-day basis, we lack about 30% of drivers. So the demand can't be met in 30% of the cases, so which is quite severe. So that's an important challenge to cover. Uh, Society is also calling for, yeah, that we as a sector are more responsible towards the impact of aviation on the environment, not just from a sustainability perspective, but also the people living at the around the airport or working at the airport. Our labor inspection has poses us a requirement specifically on improving the air quality at the airport. So that is a big theme in our portfolio. And of course, customer experience. It's all about serving the customer. Has is high on our priority list. So I'm just going to showcase a couple of use cases that we've been testing over the past years. We started, at least I started in 2020 with first integrations into the airside environment. And I think at that time, integrating into a very busy hub operation showed that we have a lot of challenges to cover in integrating the technology into an environment where people are always in a hurry, do not have time to give priority to, for instance, an autonomous vehicle that takes a bit more time to navigate throughout the traffic. We've worked in different areas. So the previous picture showed on the airside environment. This is in the baggage halls. We have initiatives operational, or we tested them in the terminal. Another terminal example, here we have in the maneuvering area a grass mower that ensures that the grass is at the correct height to mitigate also the risk of birds in the maneuvering area. Trying to improve the working conditions by implementing collaborative robots, making sure that the people don't have to carry as much baggage as they did before. People transportation use cases, and we are currently working on these use cases where we have a robot that detects FOD, foreign object debris, and it can remove it. We are specifically integrating it into the apron environment, the airport stand. I want to take you to a specific use case, a bit a deep dive. I think the other use cases show that the technology is actually almost ready for implementation, near to ready for implementation and scaling. In some cases, it needs some additional development, but we're there. It's no longer a future vision. We're ready to start implementing. So on one hand, we're trying to work on the use cases that are ready for implementation, and we're working on getting our organization ready for these implementations. But on the other hand, we also see in the future big challenges that where there are no solutions available in the market just yet. So what we've done recently is we did a proof of technology on building a solution that can support in the connecting of the aircraft to the ground power. So we had some assumptions that we wanted to validate. Is it even technically possible to tackle these four activities? Can a robot or such like asset navigate on the apron and position in the right position at the aircraft? That was a first challenge with carrying the cable of the FPU or the eGPU. Then it needs to detect the access panel with AI. So we had camera recognition detecting the access panel. We were testing with how to open the access panel, and then of course, can a robot plug the cable into the socket? So these four teams we've tested in different lab environments. We learned a lot of things there. In the meantime, I'm checking my time. I want to give Dan enough time to also present part of his presentation. So I'll go very quickly through these. What we learned here is that we need to ensure that the cable which the robot is dragging doesn't enter in the safety zone. So we need to carry it at a specific height, not to, yeah, make sure that the vehicle stops while it's dragging the vehicle and it enters the danger zone. Detecting the access panel, well, the thing is, not each panel is the same. So the system needs to be able to, yeah, make sure that it can recognize with different liveries, different positions, different ways to open it, the access panel, and also know how to open it. So that's a big of one of the challenges. We looked into different types of gripper. You saw that in this picture, in this specific configuration, it has 3 buttons that need to be pressed, and then it needs to be opened. So finally, we came to the conclusion that we use a gripper that has a pricker, so to say, that presses each button and also has a suction cup that can open the panel. And the final thing was being able to plug the cable into the socket. It's needed to know which way to navigate and position itself for a smooth connecting process with the right amount of pressure. Um, I'll quickly show you how that eventually turned out. So you see here the test setup. We had a demonstration. You see that there is a mock-up of an airplane, which is an actual part of an airplane, of the fuselage with an access panel. The robot is already positioned. It has opened the flap and it then connects the plug into the socket. Up till here is my part of the presentation. I'll stop sharing so that Dan can continue and has control of the presentation himself.
Thank you, Rosina. Perfect. Dan, you're on. Mute though. There we
Yes,
go.
perfect. Thanks. I hope my screen is on.
It is.
So Racina told a bit about some specific use cases, and what I'd like to do now is walk you through what we need to make these use cases actually function successfully in our operations. Because I think a lot of people that work with autonomous technologies might agree that simply buying these technologies often doesn't solve your problem. The integration into our non-autonomous world is often quite challenging. And I always like this little loop in the background, which shows a grandma helping an autonomous delivery robot, I believe in Russia, cross the street. And we need our own grandma. We need our own help with integrating autonomous technologies into operations. And we've been doing that by working on a autonomous technology enabling foundation. Because without governance, autonomous tech will probably outpace our Schiphol's ability to manage it. And perhaps that's not only us, that's might be the similar in your case as well. And we see this happening because of the rapid pace of development. Not only us, but also our partners, airlines, and other stakeholders are all working with these new technologies. They're implementing it. But without setting proper guidelines and regulations, we might face a very chaotic environment if we do not organize and regulate this properly. We also see that our organization is not fully equipped yet to handle these new technologies. They don't have the proper systems in place to handle those. Similarly, infrastructure needs some adjustments to fully facilitate these autonomous operations as well. And we know that it's coming, but we need time to prepare. And if we don't start doing it now, we might be too late and we might end up in a chaotic environment. So we want to do something about this. We created this framework for enabling autonomous technologies. And the basis of that is, of course, these autonomous services themselves. So this could be a fleet of baggage trucks that drive around by themselves, or an autonomous shuttle bus that we operate currently at Schiphol. But we need additional systems. We need systems for governance and operational supervision. So an autonomous operations control center, some things in place for safety and security, and also just enabling this change, because it requires quite a lot of change, also in the people side. So we need to manage that properly. Then at the bottom, it's not just about the governance and operational oversight, but also basic infrastructure there that enables these technologies. Connectivity and data exchange, perception and spatial intelligence, stuff like vehicle to infrastructure technologies, and also simply physical infrastructure that sometimes needs a little bit of adjusting, because humans behave differently than autonomous vehicles, for example. And we've seen that happening in practice as well at the airport. So we need some change there. What we've also seen so far is that often changes in a large organization such as Schiphol, they are very fragmented. And we see it happening around different domains. Innovation is happening, but this is not centralized. And if we want to support autonomous operations, we are now at the time where we hopefully can still support that and enable that in a central manner, and make sure that we enable these technologies in all of our domains and also for all of our relevant partners at the airport. Then stepping away from it just simply being a framework, of course, we've also tried to actually start working on this to prepare for this future. We've done that in a couple of areas. One of them is developing sort of a first version of what an autonomous operations control center could look like. This is basically a central hub where we oversee autonomous operations. So we tested a system where we can monitor autonomous technologies in a way where we also are very conscious about the data usage. We see that autonomous vehicles consume huge amounts of data, their LiDAR, their cameras, sending information every second. How can we monitor without creating a huge overload on the system? Similarly, we looked at certification and an audit framework. These technologies are new, especially for safety, and especially in an airport environment, that can be a little bit scary. How can we make sure that they integrate safely, but also how can we make that in a consistent way and try to speed up this integration? For this, we've created a framework that can be used by us and also every other partner at the airport, where we set a set of requirements that vehicles or other autonomous technologies need to adhere to as a minimum, and also offer some guidelines for other specifications. Once they are implemented, we often see that they get into this stage where we test with stage gates, and there's might be a safety driver, for example, at the beginning. And then at one point, if we're confident enough that the technology works as planned, we can remove the safety driver and they can actually start to drive fully autonomous. But we want to do this again in a very clear, organized way, making it as safe as possible, but also ensuring that this is consistent and data-driven. So we build a prototype of a system where we collect data from vehicles, the amount of hours they've driven, under what conditions they've driven this, to build up confidence and progress to next stages of implementation. A final category that we've also built a prototype for focuses more on orchestration of these autonomous technologies, which is orchestration on a traffic level. How can we make sure that vehicles integrate nicely into a mixed traffic environment, but also on the ramp itself? How can we ensure that there's not just a bunch of robots walking around on an aircraft stand, all being a nuisance to each other rather than working together? Of course, this is even more true in an environment like Schiphol, where there's a lot of partners working together during a turnaround, for example. We have the handler, but there's also all kinds of other services that get into the stand and need to perform operations. So we want to wait for all of these robots to communicate with each other and to also make sure that we create this optimal flow of all these different processes. The one that I mentioned quickly before is how can we orchestrate traffic? We've seen that autonomous vehicles are already doing a great job, but really nicely integrating into a very dense and difficult traffic scenario with airport vehicles is a bit challenging. And what if we could optimize this? What if we could optimize the flow, creating this perfect intersection, as you can see on this loop here, hopefully a little bit less chaotic, but the idea here is this perfect flow. In addition to this, we could prioritize certain vehicles in certain cases, breaking the general traffic rules. For example, if baggage is going to be late, or there's a bus with passengers that's running late for their flight, we can make sure that they arrive on time by orchestrating the traffic flow. And linking this again to the foundation and to the challenges, we see that we have challenges that we need to deal with. Autonomous operations we see as one way to solve this, but then we need technologies under that. So part of the foundation, and in this example, we're talking about the traffic orchestration system. So orchestrating traffic information system, Schiphol in this case, or in short, OTIS, so I don't break over these words every time. And what we can do with this is avoid some challenges that we see in these autonomous vehicles or autonomous fleets. So, for example, avoiding deadlocks at an intersection, enabling multiple fleets to work together, enabling the safe operation of autonomous vehicles in this difficult traffic environment. But also, we can improve efficiency, especially around intersections, enable prioritization of vehicles, and enable overall maximization of efficiency across the airport, across actors. To make it a little bit more tangible rather than just a vague story about traffic orchestration, how we picture this is it's a system, it's a central brain that works together with our planning system. So it tells the orchestrating system what tasks need to be done, where vehicles need to be at what time. Then the information, of course, is also flown back into these planning systems. The system might know where these vehicles are, and they can update it, data to be used for the planning system again. Then there's external monitoring systems as well. These can be cameras or other sensors that provide information back to the system in case, for example, an intersection might be closed or there's a vehicle stuck on the road. This is all important information where a human can make decisions, but autonomous vehicles might struggle a little bit more. So we want to help the system and communicate back to vehicles. And then the system converts tasks that need to be performed back to vehicles in certain actions. This is, for example, on an intersection level, what vehicle can progress first, or what vehicle might need to slow down a little bit so that they avoid each other at an intersection, and really create this nice, perfect flow in these situations. All with the goal of creating this nice traffic flow, and especially, of course, should be efficient, but above all safe as well, and enable this difficult integration into traffic. That's it.
Perfect timing. You were exactly to the minute.
Nice.
Thank you so
That's
much,
weird.
Rosina and Dan. Excellent video support, and you raised every conceivable question. So with that, we'll move on and now talk about Brussels. We'll take questions, ladies and gentlemen, at the end, and please go ahead and enter any question you have in the chat as we speak. So with that, we'll move over to Brussels, another huge and important airport in Northern Europe. Brussels Airport Company is handling more than 24 million passengers a year, and we know that it is also a shared facility with great numbers of military and state aircraft moving through the environment. We have an environment that is also as complicated as Schiphol in every way. Our speaker is Camille Lubon. He's accessibility and mobility expert at Brussels. He is focused on strategy at the airport and plays a key role in accessibility for passengers and cargo through, quote, innovative solutions and long-term mobility planning. He's going to present to us on topics that include what we're learning from deploying autonomous vehicles, airside, landside at the airport. We're looking at operational safety, governance, sustainability, environmental constraints, And how do you balance, as we just discussed, the operations and ongoing use of technology with the people involved, whether they're on the labor side or the passenger side? So with that, Camille, if you'll take over, thanks so much.
Thank you for the introduction, Luke, and good morning, everybody. I hope you can see my screen now.
Yes.
Okay, perfect. So good morning, everybody. Camille from Brussels Airport. I will talk to you about our autonomous mobility project at Brussels Airport. And to start, I can only agree with the speakers of Schiphol already on the general challenges, let's say, and the framework that needs to be put in place for autonomous mobility and autonomous vehicle at the airport. I will start with a short introduction of Brussels Airport, of our strategy, and how autonomous mobility fits within our strategy. And then I will discuss two of our autonomous projects that we did at the airport, both passenger transport. One pilot was on the airside of the airport, one pilot was landside. We're also trialing with autonomous cargo transport, but that trial is still ongoing and will not be part of this presentation, also given the amount of time all the speakers had. So very short introduction of Brussels Airport. As Hugh already explained, we have here we have our airport with our intermodal hub, our future intermodal hub, where our train station is located, our bus station is located, etc. So everything is located here. Let's say we have two piers, one Schengen pier, one non-Schengen pier. But we also have the military part, which is here located, the 15th wing of the Belgian military force. We have our cargo site. We have also around 1 million tons of cargo transported a year. So also a huge cargo airport. And then on the other side of the airport, we have our ATC, or air traffic control towers. So we have one central terminal with some remote areas, let's say. As an airport, we are now working on three major pillars. The first one is hub performance. We want to improve our position as European hub, both airside, with having more flights and connecting Brussels with Europe, but all over the world, but also on landside, by connecting the airport by ground transport. Diversification, where we are working on diversifying our activities. For example, we have more and more office space that we rent out for non-aviation related companies. And then thirdly, as a lot of airports are working on sustainability, we also try to embed sustainability in everything we do. And we really believe that mobility is crucial for all the three pillars, and that autonomous mobility or autonomous vehicles do have a place within this strategy. Our first autonomous mobility trial at the airport was on the airside. It was in the end of 2024 till mid-2025. We drove around with this OMEO shuttle with a capacity of 8 people, and we transported staff from a checkpoint, airside, landside checkpoints, towards their offices on the airside. It was a shuttle service. It was performed under the Stargate program, a European Union funded program. So therefore, we could do this test within the Stargate platform. Why did we choose for an autonomous shuttle bus airside to start? Because in terms of complexity, we see three levels of complexity. The first one is putting autonomous vehicles airside in environments or on routes without interference with air traffic. And that's what we did with our autonomous shuttle bus. Secondly, you can implement autonomous vehicles that are involved in the turnaround of an aircraft, as we saw that Schiphol is also working on. When there is an aircraft in turnaround, it's standing still, so it's not moving, but we have autonomous vehicles moving around at the maneuvering area of the aircraft. Thirdly, and most complex, is of course when we have autonomous vehicles or autonomous mobility really interfering with air traffic. For example, a taxiing of an aircraft, of pushback of an aircraft with an autonomous vehicle, which is more complex, of course. So therefore, we started with the autonomous shuttle bus for staff, for people transport, and they traveled over the green route I would say, from the checkpoint here all the way to the boat of the piers with the offices of the handlers located there. This was the shuttle bus to give you an impression. The conclusions of our POC airside, we made a difference. We tested, let's say, 4 different categories, I would say, or we tackled it from 4 different angles. Firstly, operational feasibility. We were very happy with the results. Actually, we had more than 1,000 kilometers driven without incidents. There was still challenging, and that's what we also heard in the previous presentation, that the human-driven vehicles versus autonomous-driven vehicles are so challenging. We saw the interaction between these different types of drivers, let's say, or behaviors is still challenging, because as a human, you react differently to situations in an autonomous vehicle. So therefore, it was quite important to keep that always in mind and to monitor it closely. And then with the technology we used, or that Omeo used, some weather conditions still limit the functionality. When we have really heavy fog or heavy winds or snow, then we had to stop the tests from time to time because of the technology seeing heavy fog particles as an object or an obstacle, so it would do emergency brakes, or when it was very windy, sometimes the vehicle was a little bit pushed out of its route, let's say, so it did also some emergency brakes. Technologically wise, we saw clear progress, so it took us more or less 2 weeks to teach the track to the vehicle. So how it worked with the technology of Omeo is that you teach a track, let's say, to the vehicle, and then it drives on these imaginary rails, I would say. So it has to follow always the same track. It works then with GPS and lidar systems. But it went quite fast, to be honest. In 2 weeks, we had the full track taught, and we were operational in 2 weeks. So that was faster than other implementations of our supplier. And in general, we had smooth operations. We had the speed up to 25 kilometers an hour. There was smooth acceleration, smooth braking, limited false object detection. Only when there was heavy fog, or when what we sometimes encountered was when it rained, there was some water on the ground, and then the reflection of the sun sometimes caused an emergency brake. But all in all, we were quite happy. And then stakeholder acceptance, also very important. That's because a lot of people can be afraid of the technology. So we had, first of all, a good collaboration with our safety operators. That's also important to mention, that during the test, there was always a safety operator inside of the vehicle to intervene if needed. That was from our operational and compliance teams, was one of the things we had to put in place. So one of the restrictions, I would say. But we used our current bus drivers for this job. In general, people who used it had a positive experience once they used it. So we saw a lot of people a little bit afraid getting into the vehicle, but then once they saw it, and once they saw how it reacted, once they saw how the technology worked, they were quite impressed with it, and they were quite positive about it. So we got, in general, feedback from our airport community that was mostly positive, both from the users as from other airport traffic. User acceptance, we see also, the users really accept the technology, and I will try to go a little bit faster given the time I have. On landside, we also did tests with autonomous mobility, because we see that autonomous mobility can really help us in solving some of our accessibility challenges. We will have more and more cars, although we try to aim for a modal shift. And we try to connect our remote parkings and remote areas with autonomous vehicles on landside to decline the congestion at the entrance of the airport, but also to provide solutions for staff and passengers to go from more remote parkings towards a terminal zone. Therefore, as a first test landside, we connected 2 of our staff parkings with the terminal. As you can see on the route left, it's on public roads, or partly on public roads. We had roundabouts, we had mixed public traffic from passengers to staff, to taxis, to buses, trucks, etc. So quite complex environment. And also there, we tackled from 4 angles or learnings. We had more than 1,500 kilometers autonomous driven without incidents. Still, the interaction remains challenging between human drivers and autonomous drivers, especially on the roundabouts. We saw sometimes that the autonomous vehicles should be more fast to go. It was, let's say, it should go faster on the roads. In my opinion, the vehicle was quite how do you say it, risk averse, where you as a human you enter. If you see that you have place to go in the roundabout, you just enter. But for the autonomous vehicle, it took some more time. And then there was no legal framework in Belgium, meaning the permit is quite a challenging process because we are traveling on public roads. We need to have a permit from the public authority, the government. But yeah, there is only a test framework in place, but no real legal framework, let's say, to go for autonomous mobility. And therefore, we also needed to have always a safety operator on board. That was one of the things that we had to do for getting our permit. Also, at technological wise, we saw some improvements with regarding to our airside tests, but still changes in tracks require intervention of the engineer because of the technology that Omeo used. And remote operation is ready to implement with Omeo, but it requires a very good connectivity coverage with 5G. That was also quite challenging sometimes at the airport. And for the rest, I think it's very comparable with our airside tests. But of course, on landside, there were more people walking around, and we saw that there was limited respect for traffic rules from the other traffic. We had jaywalkers, we had people with headphones on their head just crossing the street without looking. So then you see, as a human, you can maybe anticipate earlier, or you see someone walking with headphones, or that he's going to the road. Then you can anticipate on that. At the autonomous shuttle, didn't really anticipate on these kind of situations. And
Great.
to conclude, this is my last slide, so I try to finish. In terms of complexity, we did the first 2. So we did a airside test with staff, with a steward on board and mixed traffic, but on private roads. Then we moved one step further to go into mixed public traffic on public roads, where the complexity was higher. We achieved a speed of 30 kilometers per hour. And we did remote testing. The steward was still on board, but we did some tests with remote operation. So there was a remote operator that could intervene if needed. And And for the next step, and this is what we are currently working on at Brussels Airport, is to connect these remote areas with the terminal with fully tele-operated or remotely operated service, also a mixed public traffic. Apologies. And we should therefore achieve a higher commercial speed. So I think that's also a big challenge for us to go to 50 kilometers an hour, more or less, let's say. So that was what I wanted to share with you. And I will give now the word back to the moderator, to you.
Wonderful. Camille, thank you so much. So we've had a comprehensive picture from 2 critical airports that are innovating as fast as any place in the world. And now we'll turn to Daniel Sanchez Clemente, product manager at Tracked Easy. Daniel leads the development of Easy Tow driverless tow tractors. He's been looking at Easy Dollies. They're looking at it as a company in multiple environments, not just airports, but in these critical technologies. When you're talking about moving airplanes, huge value, huge sensitivity, huge risk. Moving baggage on the field, the same scenarios. And so we're going to take a look at the adaptation process across the airports and in industry. And Daniel comes to us as a critical manager in deployment of the world's first AV vehicles in these environments. So looking at operations, looking at customer needs and what we need to ensure adoption and satisfaction. I would like to introduce Daniel Sanchez Clemente. Daniel, please take over.
Thanks a lot, Hugh, for the introduction. So, yeah, autonomous ground handling. If you haven't started yet, you're already late. I know it's a provocative statement, and I'll get into that in a second, but we have heard, from Schiphol right now and from Brussels, how they've started their automation journey. So I'll get to that in a second, just briefly about myself. So as you said, Hugh, I'm the product manager at TrackDeasy. So I'm responsible for the product development activities at TrackDeasy. TrackDeasy is a joint venture between TLD and EasyMal, and I'm based in Berlin. So hopefully you're asking yourself the question, am I really already late? Or if you've started already, perhaps you thought you were ahead of the curve. The fact is, if you just look at the news, last year alone, more than 20 airports announced that they were launching autonomous vehicle projects. Certainly in Asia, we see a lot of movement there. Airports like Changi, Hong Kong, airports in mainland China are approaching fleets of close to 100 autonomous tow tractors. Also, Japan, the Civil Aviation Bureau in Japan has released, for the first time in the world, regulations that enable, through a really formal process, level 4 autonomous operations on the ramp. And if we focus in Europe, which is, of course, what we're talking about today, I do see a lot of movement in Europe right now in this area. Certainly, TrackDeasy has a growing number of projects in Europe since last year, especially, and we've got approvals ongoing with a few regulators in Europe as well. So the fact is, things are moving forward. If I go on to the next point, you might be asking yourself, what can I use autonomous GSE for? Certainly from TrackDeasy's point of view, any driverless ULD transfer or driverless towing applications can be addressed with autonomous GSE. We've got on the left-hand side TrackDeasy's Easy Dolly, where you transport the ULD directly on the bed of the vehicle. And then on the right-hand side, we've got TrackDeasy's Easy Tow that has been widely implemented for towing baggage carts, cargo dollies, and is also widely implemented at industrial sites. So we have customers like BMW, John Deere that use this to move components around their factories. And I mean, with the tow tractor on the right, we have customers that are doing like 300 kilometers a week with these. So really heavy rotation on these, really heavy use on these. In terms of looking at the opportunities for automation at an airport, what I've done here is I've split it into cargo use cases and baggage use cases. For the sake of time, I'm going to have to go quite quickly through these, but I think it's a good, idea to show which ones are more applicable for towing and which ones are more applicable for actually just carrying the ULD or transporting the ULD directly. We've got the belly cargo transfer use case as the first one on this slide. That's really about connecting those cargo areas together with the passenger terminals. So we're talking about large distances there, and there certainly you want to be towing, and that's where the Easy Tow autonomous tow tractor is really attractive. Compared to freighter cargo, where you're talking about short distances and often managed by less stakeholders, you're just really within the cargo facilities of an airport. That's where the Easy Dolly can really become attractive, especially because in those use cases, you can look at full automation of that transport, all the way from the caster deck or from rollers, all the way to the aircraft stand and docking to the cargo loader. That's what some of our customers are setting up today. In terms of baggage, we've got loose baggage, containerized baggage, not much difference there. You want to be towing those with a tow tractor. And then we've got tail to tail. The difference between the previous two baggage use cases is that with tail to tail, you don't have to go through the baggage hole. You're just connecting aircraft stands together. So yeah, I mean, these are just some examples. There's more than these as well. But you might be asking yourself the question, why automate? I'm actually going to skip this because I feel like Rosina did a great job of explaining, the high staff turnover. I was going to talk about human error, but I think we're a bit short on time. So just moving on to actually what I think will be quite interesting for a lot of audience members today, which is achieving level 4, how we get there. And I mean, just for the sake of, being clear, what we mean by level 4 is really fully driverless autonomous vehicles with no one on board. And the difference between level 3 is that you have the same vehicles, but in level 3, you still have somebody on board as a backup. And I mean, to state the obvious, if you want to get the benefits of automation, you need to be in level 4. You need to have, you can't have anybody inside the cabin of the vehicle, right? So, I mean, this is just an overview of where we have airport deployments today and which ones we have at level 4. But I want to focus really on the regulatory landscape, which is one of the areas where, we see challenges today to get to that level 4 operation. The fact is that if we're looking for regulations, there aren't really regulations out there. I mentioned Japan, that's an exception. And the fact is that different countries have different approaches. So we know for a fact that in some countries, the airport operators need to involve the aviation authority very closely, and the aviation authority has to give the approval. In other countries, it's actually more fluid than that, and the airport operators have more authority. The fact is that regulations take time, and the industry is actually moving faster than the regulators. So in this regard, it's up to the users, whether it's ground handlers or the airport operators and the OEMs. They need to support regulators on this journey. The good thing is that IATA, for example, is now catching up. So IATA now provides guidelines for getting autonomous GSE onto the ramp in the form of the Airport Handling Manual 908. I mean, it's just the beginning. There's room for improvement, but at least there's a framework in place. And I think, what we've seen, what really helps smoothen the whole process for getting these vehicles operating autonomously on the ramp is, regulators want to be working with an OEM that they can trust. So things such as certification, it was mentioned in one of the previous presentations, in Europe, especially CE certification is so important. I mean, it's a must have, and you need to be able to explain what are the standards that you're following, which make this autonomous vehicle safe. And that relates to the next point of extensive documentation. You want an OEM that's going to be able to provide all kinds of schematics about how the software works, all kinds of schematics relating to cybersecurity, risk assessments, these kind of things. So it's definitely something to look out for as well. And the third point, obviously, expertise. OEMs that have experience across the world with deploying these units and navigating these conversations about approval. That's definitely something that will help you in navigating this regulatory landscape. So if you're asking yourself the question about how to start, I mean, I see it as something pretty simple. You got to pick the right partner, like I just said, and then you got to pick the right use case. So the third point here is about keeping things simple, and that definitely applies to the use case as well. I think I liked how Camille broke it down in his last presentation. You have activities airside, you have activities on the equipment restraint area. These are all different aspects that can add elements of complexity to the project. If you have a use case that is completely landside, that's a great place to start, because you can start level 4 straight away, and you'll see that a lot of the learnings in level 4, a lot of the learnings about implementing autonomous vehicles, you will first see in level 4 operation. So the last point in terms of change management, proactive change management, we do see that if you monitor closely at the start, you'll be surprised how quickly people get used to operating around autonomous units, how quickly they just integrate it into existing processes. So to wrap up, as I began my presentation with, you're not early anymore. If you haven't started, you are already late. We do see every day, everywhere, autonomous vehicles moving baggage and cargo. We are seeing proof of concepts being replaced by fleet deployments. And the fact is that the early adopters today who are making all the learnings, they're going to be the ones defining the standards of the future. So really want to encourage everyone to be part of that change and not risk being left behind.
Excellent. Thank you so much. So we're going to briskly move to some of the questions that have been raised while you spoke. And what I'd like to do is ask each of the speakers to give a very quick answer to some complicated questions. And the order of which I'd ask you to answer would be just the order in which you spoke this today. So Rosina first, then Dan, then Camille, then Daniel. And so first question would be, how do you manage the orchestration of vehicles with low latency requirements? Briskly, Rosina, any observation there?
Yeah, so if you want to orchestrate not just only the autonomous vehicles, but also the other vehicles, you have to, of course, have very low latency in transporting the messages that you want to get to the vehicles. We are using a private 5G network. We're testing the requirements of that network and how that works. So our aim is to operate via a private 5G network to limit the risk of having too much latency and
Good.
creating risks.
Dan.
Yeah, and I think in addition to that, the nice thing is that with orchestration, often latency is not the biggest issue because you orchestrate way in advance. So before a vehicle approaches the intersection, you have a lot of time. So if it is about the millisecond, then you're doing it wrong already. Like the vehicle itself needs to have very low, like be very quick to respond to what it sees itself. But orchestration happens more in advance. So the latency generally is not the big issue there.
Very good. Camille, any comment?
No, I just want to add. We also used our private 5G network, and that's really crucial if you compare it also to other deployments where they didn't have 5G or private 5G. They had a lot of challenges with this latency indeed.
Excellent. And Daniel.
So, I mean, I think the topic of latency is a really good one. I think it really is up to how much you actually want to delegate, to the fleet management system or the orchestration system. A lot of things like intersection management can actually be done at the vehicle level. And then you don't have this topic of latency at all because it's done physically embedded on the vehicle.
Very good. Thank you. That question was from Alan Abasek. From Joanna Statnik. Quote, do you think the way we design apron stands today will change when aircraft are served by AVs and robots? Again, same order. Rosina, quick question.
Yeah. So we do see a lot of challenges with the way the infrastructure is designed. For instance, getting into the baggage department, you have to go through a very narrow hallway. And if you look at autonomous vehicles, they have a safety zone. So entering that very tight hallway, it will stop because it thinks it's obstructed. So these types of things really impact how we look towards designing the airport. It's not that we have a greenfield environment. We can't start anew. So we have to deal with it as we go, making some changes over time. But if we look towards long-term projects, infrastructure projects usually take a long time to prepare, and they are planned for decades ahead. Then we take into account how we would design it if we look towards an autonomous operations.
Very good. Dan, this is your specialty.
Yeah, I think like redesigning a full apron, I don't see it happening too fast. Like it's big changes, a lot of costs, so that won't happen. I think the smaller things will probably change, or you see some changes there. So in a way that how robots or vehicles can easily interact with some of the other equipment and materials on the stand. So maybe putting the GPU on the passenger boarding bridge, what you see at some airports, making that easier, no cables laying around on the floor. I think those type of changes we'll see, not major changes to the general stand design.
Very good. Camille.
Yeah, I'm not really involved in the design of the airport apron stands at our airport, but what we always give as a to our suppliers that they need to comply with is that we don't do any infrastructural changes. So we think that autonomous vehicles should adapt to the infrastructure. Okay, there can be maybe small adjustment here and there, but in general, we believe that autonomous vehicles should just adapt to the current infrastructure, and that it also will be possible in the future even more.
And Danielle, you are doing those adaptations, so go ahead.
Yeah, so I mean, I completely agree with Camille. I mean, of course, we would love to just redesign everything so that it accommodates, autonomous vehicles, but that's not the reality. We need to work within the constraints that are there. Sometimes it involves changing some processes. Maybe two-way roads need to be changed into a one-lane road, that kind of thing. But we try to really keep that to a minimum because that's just not really scalable.
Good. Quick question, but specific one, not to everybody. On landside operations with OMEO shuttle, does the permit you obtained from the authorities include any restriction or constraints for transported passengers?
No. If you mean by in which type of passengers, no, it was publicly available, so everyone could use it. It was mainly used by staff of our airport, of course. The only restriction or requirement that we had was that they should wear a seatbelt. But for the rest, there were no restrictions on that side. No.
And were they willing to wear the seatbelt?
Yeah, they were willing. Yeah, and that was good that we had the safety operator inside because then he could have a look. But otherwise, there are also solutions with detectors inside on every seat, for example.
Good. Joanna Statnik asks, does autonomous vehicles on airside need Civil Aviation Authority permission to operate? Rosina?
So it's the question if it needs
Civil Aviation Authority
So
permission.
in our case, in the Netherlands, within our airside environments, we are actually in control, but we do have the Inspectorate of Environment and Traffic that manages all or oversees all the changes that we make. So we do either inform them or we have to go through a management of change process, depending on the impact of the change that we are proposing. So in some cases, it's just showing them or telling them what we are going to do, and they're fine with that. In other cases, they might want to come and have a look. We did that with the Inspectorate when we were implementing taxi-bot operations. But yeah, dependent on the use case, there is a different process.
Right. I'll interject just for a second. This past week, San Francisco Airport is allowing Waymo to operate on the airport grounds. That's new, and Phoenix, Arizona has had a very good experience with Waymo. But these are recent evolutions and making a difference. I'm gonna jump to a slightly different question, but it's always present in this environment. Ruth Bridger asks, isn't there a cyber risk when using remote operation of airport shuttles? And then I'd like to go through our roster again. So Rosina, any observation there?
Well, maybe Dan can take this question for me.
Okay, Dan, you're up.
I think that the risk is always there. We check with our suppliers always on what they do to prevent this. And of course, having the private 5G network will help with this as well. So it's a bit on our side and a bit being very careful with the supplier selection and what the measures they take to prevent it.
Good. Okay. And Camille, any thoughts?
Yeah, I'm no expert on this matter, but of course there are risks. But with our cybersecurity team, we address them all. The private 5G network was one of the good things we had. And yeah, with the supplier, you have to indeed see how is it encrypted, how is it secured. But as every technology, there are indeed some risks, but you can mitigate them, so it's safe, let's say, to operate.
Daniel, any observation there?
Yeah, I mean, this is where I encourage everyone to just talk to their suppliers and see, how it's done, what safety measures are in place. I'm sure there are different approaches out there, but the supplier should be able to explain that clearly and be able to talk to the relevant cybersecurity teams and build confidence in the solution.
Broad question, just as public acceptance of autonomous vehicles, landside and also seeing them on the tarmac for things like easy tow. How are you doing in improving public acceptance and any great hurdles? So, Rosina, let me start with you.
So we haven't had any implementations on the public road yet. So the public area is the users of the airport. It's airlines, ground handlers, now many service providers and partners there. I think the POCs that we do are a way to get them familiar with the technology. We try to explain the implications because we do need them to also be aware of what their behavior implies in interacting with autonomous vehicles. So I think this conversation is very important to keep going to improve on the acceptance of these vehicles. We do interviews. We see that they're at first are a bit apprehensive, but once they've learned how stable and secure it operates, they become quite fast regular users, and then it becomes the norm, and they're like, well, it's just another vehicle driving me from A to B.
Got it. Dan, any observation?
For what I get from observation from people is generally more skepticism rather than fear surrounding it. So feedback from some of the staff is more that they are not sure if it's going to do it properly or how well it's going to do it, or just the I think also a normal feeling like, okay, let's wait and see. I have to see before I believe it. Fears are generally more coming from our safety staff. Our fears, I mean concerns, and of course critical questions, which are okay.
Got it. Camille, observation there.
Yeah, same for us. Concerns from safety people, and as I said during my presentation, once the users have experienced the technology, they trust it, they think it's reliable, and for the other drivers on the road, airside, it's quite easy because it's a limited amount of people that can drive airside. So we had very good communication campaigns. We informed everyone, the airport community. Landside is of course more difficult because there's on public roads, but also there communication campaigns. And what we did was information on the vehicle itself. This is a self-driving vehicle. Please keep some distance, and it also helped.
Good. And Daniel.
I mean, what we say at TrackDZ is seeing is believing. Once people actually see these vehicles in operation, they actually quite quickly, get won over and see how great they are. So seeing is believing.
Yeah. What we're finding in North America is that fully 40% of people who have experienced have had a ride in AV vehicles endorse them very positively. And then I think that the significant amount of transparency that's coming from Waymo particularly is helping in the United States at any rate. Some key airports, quite notably Atlanta, have a full program to try to build people's acceptance. They bring school children into the airport environment to ride on the AV shuttles. And significantly also, that airport has 150,000 workers. It's a hub operating 7 by 24. Many of them are in the nearby community. And so they're using AVs to move the employee population, and the employee populations are finding it convenient, and they actually can call in for first mile, last mile in many situations, so that it becomes a very personal experience. I'd ask you all a final question, and that is one by one. Uh, uh, are the impediments falling away in terms of moving to the AV implementations on both sides of the terminal? Or do you see this as a slow process? Are we going to be in 2035 almost fully autonomous, or is it slower than that? So, Rosina, there's the big question.
Yeah, the million dollar question. No, I think some of the impediments are moving away as the technology is maturing. I see a change between the implementations 5 years ago and the implementations that we're doing now. So the solutions are more fit for purpose at implementation. So I think I'm not sure in 10 years time if it will be fully autonomous. I think in transporting use cases, I think yes, it doesn't need that much more. But integrating other types of robotic integrations into a hybrid traffic situation, I think that's going to be another challenge.
Very good. Dan.
I mean, I probably would have thought 10 years ago that it would have been a lot further than it is now. So taking that into account, I'm not sure, but being optimistic, I think yes. The rate that it is developing now is a lot faster, and also already the projects going on, the integrations that are happening. So hopefully in 10 years, it will be a yes, mainly autonomous.
Camille?
Yes, I agree with the previous one. So I think the technology is moving fast and faster and faster. So technology-wise, we're almost there, I would say. But in Belgium or in Europe, on landside, on public roads, there is still the lack of legislation. There is no framework. There is also no outlook, let's say. So it's not that there is no an idea, or if you can drive X amount of kilometers fully autonomous without a driver, you can get the driver out, or without driver intervention, let's say. So therefore, I think it's really legislation at this point, and I hope we are working on it in Belgium and Europe, I know, but I hope it will speed up, because it's still a slow and long process.
Very good. Daniel.
So I would say in the last year in particular, I've sensed a real change in mood. I think the industry has woken up, and I think it's being driven a lot by the ground handlers. But I think because of their drive, they're waking up, the aviation authorities, the regulators. So I do anticipate a lot of movement in this space in the next years at a high pace.
Excellent. Well, I have to thank you all very, very much. They were excellent presentations. So, Rosina Kate from Royal Schiphol Group, as well as Dan Boot from Schiphol, Camille Luban from Brussels Airport. Thank you so much. And then Daniel Sanchez Clemente from Tracked Easy. Thank you all for joining us. We thank our audience, and this is coming from Global Mass Transit and from avamerica.org. And we hope to see you again at our next seminar. And again, to the speaker.